some electrical components, and we're going to be doing some circuitry. Now, over the next few days, we're going to be doing some physical circuitry using components such as an LED, a button, a potentiometer, a few other things, including a breadboard and a microbit. But before we jump in and do that physically, I think it's important for us to have a good understanding or a good foundation of what we are going to be learning before we jump in and start passing out components. Because if you do wire these things up improperly, there is a possibility of damaging some of the components. So we're going to do it first as a simulation. So if you jump onto Tinkercad from Schoology, or you can just type in Tinkercad on your computer, we're going to go to Create, and instead of doing 3D designing, we're actually going to be doing circuits. Now, we're going to be designing using a breadboard and a microbit. On my video here, you can see it says small breadboard and microbit on the right side. If it does not exist, you can just simply type in microbit, and I can see that it exists here. There's a microbit with a breadboard. It's called a starter. We're not actually going to do that because how the wiring is done on that is a little bit different than what I want to show you. But I'm going to drag the microbit over. Let me just close this so I can get back to the main screen here. And I'm going to grab a breadboard. I'm going to put the breadboard right below it. Okay. Now, what I want to do is I actually want to rotate this breadboard here. So if I hover over these areas here, you can see that there is a square that shows up as well as some circles. That's how you draw wires. So I want to make sure that I'm not grabbing there. I want to click somewhere other than where these little pins are. So I'm going to click on the breadboard here, and I can simply rotate it by just clicking this rotate button up here. And let's rotate it like this. Okay. If I scroll on my scroll wheel, I can zoom in and I can zoom out. I'm going to drag this so that it's directly below my microbit, like that. Now, once we get into doing the actual wiring and the components in the next couple classes, we are going to have our microbit is going to be attached to our breadboard using a component called a dragon tail or a T extension. Since they don't have that in Tinkercad, we're just going to wire this thing up so that way we can learn a little bit about the circuitry components and how the electricity flows. So as I were to hover over my microbit, let me select it here. Okay, what I can do is I can point to certain things and I have red squares that show up. Okay, now there are multiple pins on this. Every single one, there's more than you can see here as far as, so 0, 1, 2, 3 volt and ground. There are a bunch of other pins that we're going to have access to when we do the dragon tail. But today, what we're going to do is we're just going to mainly focus on using the microbit to give us power in order to run the physical components. So I'm going to click on this red dot here. And then if I let go, then I have the ability to put a wire on. Now before we connect our wire to one of these spots, just something else for you to note. If I right click, it'll put a bend in my wire. And what's nice about that is if let's say I have a whole bunch of wires overlapping and I can't quite see where they are, I can hit my right click and I can bend it. So I'm going to click on here, and then I'm going to grab a ground wire, GND. I'm going to click, and I'm going to drag that one to be right. Actually, let me put it right click here and then click it there, just so it's out of my way a little bit. All right, now if I zoom out, I can grab the components and I can move them around. That's fine. However you want to do it, completely up to you. But I can also then edit and change these wires by clicking on them. So let's say I click on this one and I can move this dot wherever you want them to be. So if you don't get it right the first time, that's okay. You have the ability to go ahead and modify that. When I have a wire selected, so for instance this one right here, this is a green wire. I can change how that wire looks, okay? These are different things here, but I'm not worried about it. I'm going to do a normal one. And right now what I want to do is I want to change the color from green to red. And then I want to click on the ground wire, GND, and once I select it, I can make this one black. So those are the common colors just to signify red and black. You can see on our breadboard here, we have what are called rails, and we have a red rail here. And if I hover over it, do you see how the green circles go vertical on this one? And the black circles are vertical. But when I hover over here, they're horizontal, and it actually breaks in the middle. It doesn't go all the way across. That's important, and that's one of the main reasons why I want to do this activity too, because it's a good visual for you to see how the breadboard is actually wired up. So what we've done here, by taking 3 volts of power off of the microbit, every single one of these pins in this left side here, if I hover over this here, now has 3 volts. And everything here is the ground. Now, in order for a circuit to be possible, it needs to have a out and then a return. Okay, now this is DC power, direct current power, so there is a positive and a negative. If you were to do AC, which is alternating current, that's actually what exists in your walls. The electricity, when you say alternating current, in fact, it sort of almost like vibrates and shakes back and forth. It doesn't necessarily travel back and forth, where this will function, will flow in a circle or a circuit. Okay, so now what I want to do, the first thing that we want to wire up is I want to bring over this LED right here. So I'm going to drag this over. However, I can't have it in this direction, and I'll explain why here in a second. If I drag it over here anywhere on any of these pins, you don't have to put it in the exact same spot. There's going to be some cases where I'm going to tell you where the wires need to be in relation to what's already on there, but you can place this anywhere. Let's put it on the left side over here. And so I have my LED. I'm going to rotate it. There we go. So it's almost like a 90. And then if I move it again, you can see that it'll actually like snap into locations. So this LED has 2 terminals. Okay, we have what's called an anode and we have a cathode. You don't necessarily need to know those nerdy terms, but what you need to know when we pass out LEDs and we use them physically, one of the wires is going to be a little bit longer. Do you see how this one's bent? That signifies the longer one. That's called the anode. And that accepts positive power. So I'm going to click on here, and I'm going to click anywhere, any of these pins that are in the same row will actually feed that power. So I'm going to click here. I don't love this being black because it's actually my positive feed, so I'm going to change this to red. Okay, and then I can grab anywhere. In this case, I can grab right here. But any of these black, or any of these ones down this rail here, you can see is connected to the black wire. So I'm going to click here, and I'm going to connect that to, let me make it so it's out of the way so you can see it. Let's go up here and I'll right click just to bend my wire so you guys can see what's happening. You don't have to bend the wire, but it's just more of a visual. Okay, so I have 3 volts of power coming out of my microbit. It's powering this whole rail here. Everything that has a green circle now has 3 volts of power. I'm jumping off of it over to here, and I'm feeding the anode, the positive side of the LED. Electricity is flowing through that, back out the cathode, negative, back to the ground. Okay, so if I hit start simulation, something's going to happen here. There it is. Okay, so a couple things are happening. Do you see that exclamation point? That's not great. Let me move this over a bit so you guys can see it. Actually, I need to stop the simulation. Let me move this out of the way here. Ugh, that makes it messy. And let's do that. Okay, let me hit start simulation again so you can just watch what happens here. This is showing me some features and functions that exist on the microbit. Okay, so there is a thermometer, there's a light sensor, you can shake it, you can move it, and depending on how we would code this, certain things can happen on our breadboard. So we don't necessarily need to worry about what's happening on here. I just want to show you what that is, and we'll move it out of the way. when we get into doing the physical wiring of our microbit, stop simulation, move this back, then I will we'll be able to code certain things to happen depending on the components of the microbit. So that's what I wanted to show you there. So if it starts simulation again, we have an exclamation point. That's not good. I'll tell you why that's not good. Because in fact, we have 3 volts of power going through our LED, and that is too high. The LEDs are rated, look, it tells you right here. Okay, the current through it needs to be reduced. Okay, so because I'm a computer nerd, I know that this is roughly 2 or 2.2 in that range voltage. So the light is bright and it will work, but over time it's going to burn up because it's only rated for up to 2.2 volts and this is 3 volts. So here's what we need to do. I'm going to click on this wire right here and I'm going to simply just move this out of the way for now. Let me grab it and just disconnect it. Stop simulation. Sorry. Any changes we make, we need to stop the simulation. I'm just going to drag this over here for now. It's not letting me? Why won't you let me? Let's drag it out of the way then. Whoops. Hit escape. Let's drag it down here and just snap it down here. Okay, that's fine. It doesn't let me disconnect it off the board. I'm going to grab what is called a resistor, and we're going to connect that right here. And then, if you follow along with me here, I'm going to snap this one into the same row as the other end. So here's what's now happening. We have 3 volts of power going to here, jumping to here, and it's powering this rail here. So now this electricity can flow through this resistor and then through the LED. I'm going to change this number. So let's click on the resistor, and we're going to change this to be ohms, regular ohms. Right now it's kilo ohms. This is just regular ohms, omega. And I'm going to type in 220 ohms of resistance. I don't know if you notice what happens here. It actually changes the bands. Let me type in, let's say like 33. Do you see how these bands are changing? 330, okay? Or 1, 2, there we go, 2, 1. You see how these bands are changing? That's how you identify them. There is a coding, a color coding chart that'll show you and explain what each of those bands mean. But we just need to make this 220 ohms. Let's try this again now. I hit start simulation, and look, it's happy. We have an LED. How fun. Okay? So we have a regular LED here. I'm going to leave this one right here, and I'm going to start building below it because we're going to add different components that we can then interact with. So we're going to use this circuit right here as a little bit of a template that we can utilize and modify doing the different parts of the circuit. So we hit stop simulation. Okay, and now, again, we have 3 volts coming down this whole row. So let's just jump off of it. And let's actually do this. Let's grab another LED. Let's bring it over here. Doesn't really matter where, but I'm going to rotate it, and then it's going to make me snap it back in. So I'm going to put this one, let's put it right here. And I don't even know if this will let me. Will this let me duplicate? No, I got to drag another one. I'm going to make another resistor right here. So I'm sort of copying what's happening here. And let's make this resistance again 220. Hopefully I'm not going too fast for you. Some of you are probably just like, Mr. Hale, speed this up a little bit. Okay. And I also now want to add a push button. So the push buttons that we're going to be using in class are actually going to have just 2 pins. This one has 4 pins on it. But how this electricity is going to flow, I don't think it's this way. Ours are going to flow across. Let's see how this works. We might have to rotate this. Might need to make a modification. Ours is going to be very straightforward because the pin is right here, and when you push the button, it allows electricity to flow through. I might need to rotate this. We'll see. Okay? Anywho, let's get back to here. I'm going to grab a wire from here to one of these rows just to make it consistent with the one above it. We can click right here. Great. And I'm going to come off of the left rail, which is my positive, I'm going to drag this over. I'm going to snap it anywhere here. I can put it right here is fine. And I'm going to change this to red, just so visually we can see what's happening. So we have the red coming down the rail, through the button, and now this is going through the resistor, through the anode, and then it changes, well, I don't want to say it changes from, but this is where the transition happens from positive to negative, and then it's flowing through this. So your negative needs to be connected to the negative side of the cathode. LED, I should have mentioned, this is super important. LED stands for light emitting, meaning it blinks, okay, diode. And what a diode is it's a component that electricity can only flow in one direction. So if you have this thing flipped, it in fact won't light up. It does not elect current, it doesn't allow current to go from positive through this direction. Current can only flow in one direction, so it has to be like this. I'm going to hit start simulation again. Okay, and now looks like I have this wired up improperly. Let me rotate this. Let's go back. You see how this is on? I don't want that to be on. Let's click on the button. When we use, again, the buttons in class, you'll be able to see that. Oh, we gotta snap this up here. It's going to be pretty straightforward. And now let's grab this one, and I'll move this up so it's connected here. Okay, so we just rotated it to come out the sides. Let's see if it works now. Okay, I think this is good. We have this one's always on. It's always getting power as long as our microbit's getting power. And now let me push this button. Hooray! Great. And if I didn't have this resistor, same thing. It would say pop, and it wouldn't work. So there is our button circuit. So when you push this, it's a temporary button. This is called a normally open circuit. And when you click it, it closes the circuit. Oh my gosh, Mr. Hale, this is super nerdy. We're going to do a couple more components today, and then we're going to see how they impact our LED. Let's work off the right side. We're going to do two more components. We're going to do a photo sensor. Let's see if that shows up over here. It is. A photoresistor, in this case, is what it's called. And we're also going to do a potentiometer. Let me see if that's on here. Maybe I missed it. If not, we'll search for it. Oh, it's right there. Perfect. They're all here on the basic parts. Let's do potentiometer next. Okay? And let's rebuild this the opposite direction. But before we do that, here's what I'm going to have you do. I'm going to have you get my zooming correct. I'm going to go from this same 3.3, and I'm going to bring a wire over here. We're going to power up this rail off the same thing, and that's fine. I'm going to go from here to here, and I'm going to change this to black so we can visually see that we have the reds, 3 volt positive, ground is always negative. Let's see if we can build this the other way and still get it to work. Drag my LED over here. Let's rotate this a handful of times. There, and I can flippy it. Ugh, that doesn't make sense. All right, let's rotate it a little more. So in this case, that'll work. Our red, again, needs to go to the anode. So let's go red to red. Okay, we're switching the circuit a little bit. This is a good lesson to learn. It doesn't really matter if our resistor is on this side or the other side. So in this case, the resistor is on the positive side before it feeds the LED. It doesn't really matter. We can have those components that we're going to use. Let's grab another resistor. Be creating, impacting the circuit through the negative or the ground side of the circuit too. Here, let me click on it again. Click. Why can't I change this? It just showed up for a second, then it disappeared. There it is. I'm not sure what's happening. All right, ohms. 220. Again. Okay, now we're going to get a little bit nerdy. I'm going to grab this thing here called a potentiometer, and I'm going to rotate it so it's sideways, and let's snap this so it's like that. Okay, so I have my one terminal in the same row as my resistor, and Then what I want to do is I'm going to use this middle pin. So I'm going to grab here, and I'm going to go, let's click, and let's bring it like that, and make it black. That's kind of hard to understand. Let me move this out of the way. If you want to put it there, that's fine, but ugh, I don't love that either. Maybe I'll put it back. Sorry, folks. Just wanted to visually see what's happening. So we have the positive going through the LED, coming out the resistor, and then this potentiometer here, let me hit this, what this is doing is this is essentially a variable resistor. So resistor, it resists the current. It slows it down, so we're not going in full speed. And that's important because if the current's going too fast, as we saw, or there's too much voltage, then what will happen is it'll actually pop our bulb. Not physically, it won't explode, but it'll burn out the LED. This here, even though we have a resistor in the circuit, that resistor essentially, the purpose is to protect our LED from burning out when we have no added resistance to this potentiometer. So there's zero resistance here, and as I start to increase it, it's going to go dark. Okay? So this one here, this would be the correct way to wire this. If I were to take this out, let me click on that and hit delete. Okay, and then let me move this pin. Nope. Escape. Escape is the way to exit something. Let me bring this here now. Does it not like that? I want to go from here to here. That's what I wanted to do. Let's see what happens now. All right, it's bright. See how it's popping? Let me see if I turn it down. Oh, good. Then it goes within range. Not really. It just barely, if I click it there, it's sort of light and then it gets darker. Yeah, I don't love that. Let's put our resistor back. Click on the wire. Let's delete it. And let's drag our resistor back here. And again, let's make this thing 220 ohms. Okay, start the simulation, and we have very little resistance, no resistance, and then if I were to turn this thing up, it would change it. There are different ones, so this, for instance, this one here doesn't allow me to, yes it does, change the resistance. There it is. Let's see if it'll make us, I just changed it from kilo ohms to ohms. Let's see what happens now. Let's drag this up. That one's not, unfortunately, that one's not killing enough power, creating enough resistance for this to work. But we can change the level. I don't know. Let's try 1,000. I don't know. Let's see if this works. It's sort of dimming. Might be hard to see. It's kind of dimming. I guess the lesson to be learned here is for you to understand that there are different ratings of potentiometers too, just like there's different ratings of resistors. So the higher the resistance, the more that it'll restrict the flow of electricity, and therefore the more it will restrict the flow, the dimmer the bulb will be because it's just restricting how much electricity. So that's the circuit of a potentiometer. We have it flowing through. Let's say we're going positive through the LED, out in this case, through the resistor, and then we're going back through the resistor, through the potentiometer, and then out the middle here, back. That one's a little confusing, okay? I'm going to show you one more type of resistor that we're going to play with when we physically wire these up. And then what I want you to do is I want you to take a screenshot of your design here, so that way I can see all of it. Or you can just take a picture with your iPad. That works too. Okay, one last one here. Then we can wrap up this lesson. We're going to grab an LED and we're going to bring this over. Let's work down here. And I'm going to rotate this. Let's rotate it so that it is just like this again. And let me give myself a little more room so I'm not confusing myself with this circuit. So we have 3 circuits right now. We have one here, one here, and one here. And the main thing to note, in order for a circuit, it needs to have a positive and a negative, or a feed and a return, okay? It needs to be connected in both directions. Just connecting power to one side does not work. Okay, once again, let's wire up. So this is my positive rail. This is my 3 volts. Let's go over here, snap it there. Don't like it black, let's make it red. And in this case, let's add another resistor again, just to protect our bulb. Okay, this is going to be 220, and make sure you're changing this to ohms, not kilo ohms. So all of your resistors should look, visually, they should all have the same banding, the same colors. These are called bands. And then I'm going to go down here, and I'm going to grab what is called a photoresistor. A photoresistor, photosynthesis, that means light. So what this, and I have these in the classroom, we'll actually play with these. What this will do is, depending on how much light is traveling through this, it'll function just like a potentiometer. It'll either increase the resistance or decrease the resistance. I shouldn't say decrease the resistance. It'll increase the resistance if it's covered, but if you don't cover it, it'll allow electricity to flow a little bit better. I'm going to simply grab this one here and go over to the black. That way we complete our circuit. And let's change this wire to black so we can visually see the flow of electricity going through the anode, positive side, out the cathode, through the resistor, this is just for the protection, through the photoresistor, and then back. So let's hit start again. Okay, so let's check our things here. So this one still works. You should have all 4 of these circuits functioning. Yeah, you can see that dimming. I'm not sure what setting I'm on. I forget. Push this button. That works. Great. Now the photoresistor, I can't cover it with my mouse or your finger in this case. But what I can do is I can click on it and I can show you that the more light that goes through it, do you see that light, that bulb getting brighter and darker? The more light that is flowing through this photoresistor, the brighter the bulb will be. And if I cover it with my hand or my thumb or turn out the lights, it's going to dim it. So these are the main components that we're going to be using when we start wiring this up. It's going to look a little bit different, and I'm going to have another video that's going to show you how to actually wire things up, and they need to be in specific locations. You can't just plug things all over the breadboard wherever you want them, because that's the electricity flows in certain directions. So we have all reds here, all blacks connected here, and then we flow through the breadboards by connecting the components together. That was a very brief, but probably maybe a little bit tough of a lesson in order to introduce you to basic breadboard circuitry. This is going to be something that you're going to see if you take any classes in the high school as well. They use some Arduinos and some other things that are a little bit more nerdy than microbit, but for what we need to do in this class, microbit is perfectly fine. So go ahead and zoom in. That way I can see all 4 circuits, just like this. I want you to take a picture with your iPad. Make sure it's clear enough that I can see these resistors. That's going to be important. Or take a screenshot with your snipping tool and upload this to your exit ticket. And then next lesson, we are actually going to be physically wiring these things up on a breadboard. And then eventually after that, we're going to be doing a little bit of coding with those.